We got my carriage stop all set up. I need the depth of cut here at 9 millimeters, which is 354.3 thousandths. Well, I've got this set up for 354. The dial indicator is there and the stop is all set up. And now we're getting a nice uniform depth of cut here. Okay, that's working just like it's supposed to. Anyway, that's the way the carriage stop works, and it's working just perfect. My big challenge now is getting my width. I need that 30 millimeters, the inside diameter of that hole, 30 millimeters, just right at or just slightly under 30 millimeters, so that bearing just slight fits in there. I don't want a slip fit, I just want a light press fit in there. Well, anyway, that's what I'm working on now. Trying to figure out how to calculate that, make my mind work the right way. Alright, I got that OD, or the ID, on the bearing seat just a little bit bigger than I want. It's not sloppy in there like the other one was, it just slides in there, and it'll probably be tight in there once this piece cools off. But the depth is just perfect on it, so the depth gauge worked perfectly. The carriage stop worked perfectly. Well, I still got some figuring on how to get my cuts right on there. I don't know. Anyway, that's a lot better than the other one was, so I'm going to go ahead and trim this down and part it off, and then we'll turn it end for end and do the other side. I've got half of my first one, a little more than half of my first roller done. I just parted it off from the block. There's what it looks like, and there's what the old one looks like. So I've got to probably put it up in the 4-jaw chuck now so I can indicate this and get it concentric, so we can get the rest of the hole concentric on this side. Face this off and punch another hole in there, pocket in there on that side. I got enough left of that slug that I was using that I think I can go ahead and put another pocket in there on this side, and then I can turn it around end to end, face off the pocket that I put in there, and then put another pocket in there, and I can save that little piece, that little slug there. I messed up on my shanks here, my shafts. I'd put those in the collet chuck and cut off the end, faced it, and pilot drilled it for a 1/4 bolt. I forgot that this thing is going to be machined out eccentric. So when it's machined out eccentric, then this hole is going to be off center. So I've got to start over again, get some new bolts, and start over again on that portion of it. I can go ahead and cut the bolt off and face it off, but I can't. There's no point in drilling that hole in there until I get it set up in the 4-jaw chuck so that it'll machine the eccentric on that, and then drill the hole in so that it's drilled centered on the eccentric. Sound kind of eccentric saying that. I was able to get 2 of these roller blanks out of that piece. This is the start of it, that slug that's left over. This is the first pocket that I made in there, and it wound up being too deep and too big a diameter, the ID on it for the bearings that I'm using. Well, that's how much I had left over there. So cut that off and save that for something else maybe someday. Oh, both of these have a little lip on them where the cut-off tool left on there, and then of course I got to bore this out for that bearing pocket on this side too. This is what I'm emulating there. Whoop! That didn't dent the ways. Anyway, that's not too bad. Now I'll use a regular tool just to trim that off and face that edge off before I put the boring bar back on there. So that lip is off there. Now I can set up the boring bar and bore that pocket out. Getting the outside diameter on that is the challenge. This first one that I did, I got it just a touch larger than what I wanted. The bearing slips in there pretty good, This one here, I got it just about perfect. The bearing just finger presses in there. Now that it's cooled off, it's probably a little bit tighter, but that's good. Now I have to do the same thing with the opposite side on those to see if I can't get them a little better. If I get practice, I get a little bit better at them. One of the things I did do, I've been using this boring bar with a carbide end in it. The carbide kind of peels the metal off instead of cutting it off like a good sharp tool steel one, a hand sharpened tool steel one. Well, I prefer the tool steel ones. I think they give me a little better, cleaner cut, but I don't have a boring bar with a tool steel bit in it, and I don't really know how to sharpen one. It's something I have to teach myself how to do. So meanwhile, I've been using this one, and it works pretty good for the most part, but when you start getting in tight, in close, you just can't take a small enough shaving off there. It takes so much pressure with these on there that I wind up getting close, and then I wound up going over. If it get under just a little bit, what I did on this is I took a diamond hone and just honed the faces of that, both faces, cutting faces off on this, and that made a big difference. I could just take a really fine feather cut on that with that then. Now that's, recommend doing that because the carbide is brittle and it'll chip. Well, we've got a nice even cut in here and pretty good cutting material, so it made it work a lot better like that, and it hasn't chipped any at all. I got the two rollers finished, and they turned out pretty good. So now it's time to make the shafts that they go on, that they ride on. This is one of the old shafts here. It's a 1/2 inch by 13 bolt that the head's been turned off of it or cut off of it, and the shank here, the unthreaded portion, has been turned down off center from the rest of the bolt to 10 millimeter, which is the ID of the bearings that we're using on there. Now I went and got some 1/2 inch bolts, and these aren't exactly a match for the ones that come off of there. They don't have as long of a threaded portion of the shank on them, but this section here is plenty long enough to turn down for the roller portion. And I've got plenty of extra shank on here that this thing the bolts only come into here to tighten up anyway, so there's more than enough shank on there, threaded portion on there, to do what I need to do. Oh, now I'm going to set them up to turn that off center for the 10 millimeter for the ID on the bearing. So I've got the 4-jaw chuck set up, and what I've done is I've taken one of the original bolts and put in there, and then I've got my dial indicator, and I don't have a good way to set it up, but I've got this one with a magnetic back on it. I just set it up on my tool post and put it on that shank on the old bolt, and I've set it up so that this 10 millimeter section is centered on there. I'll just go ahead and loosen up 2 of these jaws and stick a bolt in there and then tighten them up, and that should be close enough. And then I can turn that down, the shank down to the 10 millimeter. I'll leave a shoulder on one end for the bearing to seat on the inside, and I'll have to decide then how much meat I've got in there. I think this one was drilled out for a 1/4 20 bolt, and I had originally figured on going to a 1/4 20 bolt. That's what I drilled those others out to, but I may decide to go to a 3/16 bolt instead of a 1/4 20. And I'll have to make a washer that'll fit over that so that when the bolt goes in there, it'll press on the inner race of this bearing. So what I want the bearings to seat tight in the pockets on those rollers, and then they don't have to fit too tight on that shank. What I need is a washer to go against that, and it'll put pressure back here on the back. Maybe I'll put a washer on the back of these this time to ride on this inner race, and that'll pinch that inner race so that it doesn't spin on the shank like it did before. So I've got this set up, and I had it actually zeroed out pretty darn close. I've been using a carbide cutter on those, but I think what I'm going to do, I've got a high-speed steel tool bit. Here, and I think I'll sharpen it up and use that instead. I like the way the finish I get out of these a lot better. And my carbide, of course this will be an interrupted cut, and I've already chipped the carbide on that. I had to replace the bit on that cutter once, and then it chipped again, and these interrupted cuts are hard on those carbide tips, so I'm going to set this up and use a regular high-speed steel tool bit, which is what I use most of the time. When I can, we'll try this again. I'll go ahead and start a hole in that end of that. It might be better to bore that out before I trim that down. This is the first one. You can see it's set up for the eccentric, so alright, I've set up my lathe now to make my first cut. I took my bit down and touched it up on the grinder and redid the edges on it. I'd used that for a couple of years like that, and I think they were getting kind of rounded, but anyway, I got those sharpened up, and then I brought them up here and put them on the stone a little bit, and honed them down, honed the faces of both sides down, and then rounded over that tip just a little bit. I've got my stop down here set up. I had to take the little foot off. I had to take the little foot off of it because it stuck out too far. I couldn't get it adjusted back far enough. But I've got my stop set up now, and the depth of cut on it is 876 thousandths. I've got it set up for 200 RPM. I'm going to take it in until it just touches off. There, just touching off there. And I'll take it for a 2,000ths cut, which would be 4,000ths cut, I think. There we go. Let's see what happens. I'll check it again. That's 10.9. Almost now. Okay, that's good. Just like that. Just like that. That's good. I think I'll go ahead and drill that out, the 11/64 for 1/4 inch 20, and tap it while it's on there. I haven't punched that bearing in there yet, but that'll fit in there like that. Another bearing on this end, and then nut. I'm going to make some washers to go in on that. Now, so I don't have to change my setup on the carriage stop, what I'm going to do is I'm going to pull it out, the bolt out, and then just run my tool up against it and shove it in until it zeroes out the dial indicator here. Now we'll go through this just exactly the same way. I'll spot that hole and drill it out, and I'm going to go ahead and drill it out for a 1/4 inch 20 this time, and then I'll turn that down to 10 millimeters. Well, I got 4 of these new studs done, and they turned out pretty good. Didn't make any mistakes on them. Didn't screw them up any, so I didn't have to do them over. I did buy extra bolts just in case. I've got the 2 rollers here that I made, and I got the 4 original ones here. What I'm going to do now is I'm going to make some washers fit just tight up against this inner race, and then that way I can put a bolt with a lock washer on there and that washer on there, and that'll put pressure. See, that race fits up tight against that shoulder right there to spin on that, but if I put a big washer on this side, that'll press down between and kind of load between the 2 bearings good so that they don't spin on the shafts. Those are a little bit tighter than I thought they were once they cooled off, but they're not quite as tight as I would like them. But there's a way to fix that. It doesn't take much. What I do is just take, this is an automatic center punch, if I just take and make one punch there, one punch 90 degrees from that, do it every 180 degrees, that stipples, so we call stippling. That raises just enough of a dimple in there that these will fit down in there tight then. So you don't need to do a whole lot, just a little bit like that. If it's really loose, you can do a lot of stippling in it, like knurling. In fact, I think they make internal knurling tools for doing that. That'll raise up a little bit, and then you could turn it down a little bit or polish it up a little bit. But for just that, using this little automatic center punch, it will give me plenty of extra material to stick out in there, and then that bearing will fit down in there. Even though it's a little bit loose in the bore, once it goes into those stipples, it'll fit down in there tight, and then I won't need Loctite in it. I have to change these bearings often enough, and I could put Loctite in there, but it just makes it a real pain to get them out again. This will work. This will work good. I've got a couple of these that were loose. The bearings were loose in the pocket that was made for them. I'll do the same thing with those. And then I'll load these up and just keep them for spares, and that way when one of them starts wobbling a little bit, I can just take this off and swap the new ones back on, and it doesn't cost me that much time that way. It doesn't take very long to fix those, but short daylight hours that we have here now, even 20, 30 minutes makes a difference on how much lumber I can get cut. And it'd make it easier if I know all I got to do is pull the bolt off of there, pull this off there, and stick a new one on there. Then I'm be more prone to do it before the bearings go too bad and cause maybe damage to the blade or something like that. But okay, next step is to make those washers, the thrust, kind of a thrust washer. So the next thing I've got to do is make thrust washers for those bearings, so they'll fit over the shaft that the bearings slide on, and the bolt will push that down hard against the bearing to make the bearing turn, or so the bearing doesn't spin on the shaft. So we want to put pressure on the bearing on this inner race right here, so it pushes hard against it and holds it firm so that the bearing and the roller can spin freely about that lower race or inner race. So I know the ID of the inner race is 10 millimeters, so and that's what those shafts are, is 10 millimeters. So I want the hole in this, the ID on these washers, to be larger than 10 millimeters. I got a 10 millimeter drill bit and I have a 10.5 millimeter drill bit, but I was thinking the 10.5 might be a little bit big, and the 10 millimeter might not quite be big enough. I want to make sure that it clears that shaft. So the closest size drill bit I could find is a W drill bit, which is 397 in diameter, and I think I figured out a 10 millimeter was 393. Yeah, 393. So I've got the W drill bit in there. I'll drill this hole out there, and then I want the washer to ride on this inner race, but I don't want it to extend out past the inner race. Now the inner race does protrude out past this this shield a little bit, but I don't want to take a chance on it riding on that shield at all. So that, you can say 652 is the OD on the shield. Well, I've got a piece of 5/8 inch stock. Well, anyway, that should be the right size for the thrust washer that I want for this. So I'm going to head ahead and drill this out in there with this W drill bit. Might run a bit on it just to clean it up a little bit on the outside, just to make sure it's concentric, but it doesn't really matter, so I don't need to worry about that too much. Well, I'm going to set up my cutoff tool on there and cut those off. I guess first I'll go ahead and countersink that a little bit, just chamfer that hole. Okay, those don't have to be too thick, but if I make them about the thickness of my cutoff tool, that'd probably be just about right. Okay, there's one. I gotta do something with that little flange. Yeah, a little bit warm. There's 4 of them. Let's do another one just for good measure, just for grins and giggles. Never know when you might need one. Going so well, I might as well do another one. There's my little washers. They got the rim on here from cutting it off because I got my cutoff tool turned around backwards, but that won't be too hard to peel off of there and clean up. I got those washers cleaned up, and they cleaned up pretty good. They work they're going to work fine. I took those, just a pair of pliers, needle nose pliers, and grabbed those rims there and just peeled them off there. Just got them started, broke loose, and then just rolled them. It's kind of like opening an old sardine can back in the good old days. I still left a little sharp ridge on them. Oh, I took them and put them on a stone here and just rubbed them around with my finger until I got them all smoothed out, nice and flush, and then just took this reamer. It's not a very good reamer. It's pretty much worthless, actually. It's a cheap reamer set I got someplace, but anyway, I just took that and just held it on there by hand and rubbed that in there. So they all work now. They'll all fit over there now. So that'll be nice. You'll get those bearings on there, and those will just fit tight up against that bearing race itself. So I can put these together. Well, I got the 4 rollers assembled. I got the bearings put in, and I got them put on the new shafts. And I got some 1/4 inch 20 1/2 inch long grade 5 hex cap screws and put on there. I found a lock washer and stuck on there, and then the thrust washer that I made for them. So those are together, and the eccentric works on them, so I can adjust those. And I've got 2 spares rollers, the new ones that I made. Those are all loaded with bearings, ready to go on when these start going bad. Now here's the old shafts. You see, these were drilled for grease zerks, and you could grease them, but the problem is the grease just came out around the shaft. It didn't go up into the bearings. So these new ones are built without holes in them for grease fittings. Now the thing that I'm wondering about, I got new nuts to put on those, but these front nuts that go against the stop, against the bracket on the front, they're half nuts or jam nuts or something like that. So I'm wondering if maybe I want to just chuck these up and mill them down about halfway. I decided to go ahead and trim up half of these nuts down to about half the thickness that they are, or width that they are, whatever dimension you want to call that. If this was a perfect world, I could run down to the nut and bolt store there and buy some of those check nuts like that. But this isn't a perfect world, although after spending a couple weeks down in the lower 48 again here recently, it's a whole lot closer to being a perfect world than most places are anymore. I've got these studs here that I cut off the heads of these bolts, made them into studs, and I've taken 2 of these nuts and put them on together and then clamped them up in the 3-jaw chuck. That way there's more purchase area for the jaws of the chuck, and it can hold it straight. That's the idea anyway that this fragile mind came up with. Well, I turned 4 of those nuts down to half size or thereabouts, something like that. I didn't try to get them all exactly the same, but I actually come pretty close on them. So that finishes these up, except for putting them on now.